Alright, so let's take a look at today's lesson, arithmetic sequence and series. Okay, let's define some key vocabulary that we need to know before we move on. First of all, a sequence. A sequence is a list of numbers that are in order. Okay, so for example here, 2, 5, 14, 18, 19, 44. This would be considered a sequence because it's just a list of numbers that are in order. Okay. Now a sequence can be finite, right? The word finite means ends. So this sequence ends. There's a first number, there's a last number, okay? Now the number of terms, right? So for this sequence right here, there's 6 numbers. So we can say this sequence has 6 terms, okay? So this would be the number of terms for this sequence, right? Now an infinite sequence means that the sequence continues on forever, okay? So there's no last number, it just continues on forever. The way they represent that is with 3 dots, kind of like this. So this sequence here, if I put 3 dots at the end, I'm saying that this sequence continues on forever, and we may or may not be able to find out what these other numbers are. Alright, when we're dealing with sequences, there's a very specific type of sequence, alright, that's very common. It's called an arithmetic sequence. An arithmetic sequence, right, is a sequence in which the difference between consecutive terms are the same. Alright, I'll give you guys an example right here. Let's say we have 4, 7, 10, 13, 16, 19, right? So this would be considered an arithmetic sequence, alright? Because you notice, in order to get the next number, what are we doing? You know there's a pattern, right? We're adding 3 each time to get the next number. So we add 3, we add 3, we add 3, we add 3, we add 3. So when you keep on adding the same number each time to get the very next number, right? What you have is an arithmetic sequence, okay? Now this number that we're adding each time, right? We're adding 3 each time. To figure that out, what we do is we could take any of these numbers and subtract the number before it. For example, if I take 7, right, and I minus 4, I end up with 3. Or if I take 13, I minus the number right before it, 10, I get 3. Or if I take 16, I minus 13, I get 3. So that's how you find the what we call the common difference. So this number right here, you notice we add 3 each time to get the next number. So this number right here, this value, there's a name for it. It's called the common difference. Okay, and to find the common difference of an arithmetic sequence, you just have to remember, right? We can find the common difference, right, by subtracting a term, right, by the one before it. Okay, so you notice that's what we're doing here. We're taking any of these terms, any of these numbers, and we just subtract the one right before it. And if you always get the same number, that means that the term the sequence you're working with is an arithmetic sequence. Okay. So down here, let's do a few more examples so you guys get the hang of it. So an arithmetic sequence, right? So for example here, if you want to check to see if a sequence is arithmetic, all you do is subtract the numbers. Okay? So if we do 8 minus 5, we end up with 3. If I take 11 minus 8, I end up with 3. If I take 14 minus 11, I end up with 3. I keep on getting the same number, right? So that means that this is an arithmetic sequence, and our common difference, right, represented by the letter D, right, is 3. Okay. Over here, if we try and check to see if this is arithmetic or not, if I do 5 minus 2, okay, I get 3. But if I do 9 minus 5, I get 4. It's not the same number, so this cannot be arithmetic. Okay, it might be something else, it might be nothing, but it's not arithmetic. Alright, down here, let's take a look at this example. If I do 8 minus 15, I end up with negative 7. If I do 1 minus 8, I end up with negative 7 again. If I do negative 6 minus 1, once again I get negative 7. So this would be an arithmetic sequence right here, and the common difference would be negative 7, right? So what that means is if the common difference is negative 7, this is what we add to get the next number. So you notice 15 plus negative 7 gives me 8. 8 plus negative 7 gives me 1. Negative 6, right? If I wanted to find the next number, I would just add negative 7, right? And I would know the next number is negative 13, and so on. Okay, so that's how you figure out if a sequence is arithmetic or not. It's really simple. You just subtract the numbers, right? And if you keep on getting the same value, that means that it is arithmetic, and that same value is your common difference. Okay? Alright, now a sequence, sometimes it can be expressed, right, as a general rule. Okay? So for example, right here, instead of giving you a list of numbers, right, they're saying, hey, there's a sequence, you can express it with this general rule right here. Okay? So now, this notation here, u sub n, now this letter u, sometimes different books, they might use different letters. So sometimes this could be a T, sometimes it could be an A, sometimes it's a U. So just keep in mind this letter here, it can be different letters depending on what book you're using. Okay? So the letter doesn't really matter. Now, u sub n, it's important for you to understand this notation. This notation means that n represents a specific term. So for example, if we say u sub 3, right, this means the third term in the sequence. Okay, so it's important for you to understand the notation here. All right, so u sub n just means n can be anything. So n sub 1 would be the first term, n sub 2 is the second term, and so on. So for example, down here, so we have this general rule, we could come up with the sequence. So u sub 1 is the first term, this is the second term, the third term, the fourth term. So over here, n is equal to 1 here, right? So if you plug in 1 here, 2 times 1 plus 1, we end up with 2 plus 1, so we get 3. Over here, n is 2. So we have 2 times 2 plus 1, so we get 5. Over here, we have n is 3, 2 times 3 plus 1, we get 7. Over here, we have n is 4, so 2 times 4 plus 1, we get 9. So this general rule, right, if we want to come up with the actual list of numbers, right, it would be 3, 5, 7, 9, right? So sometimes instead of giving you the list, or the list of numbers, or the arithmetic sequence, instead of giving you the arithmetic sequence, they'll give you a general rule that represents this sequence, and you can find the numbers by doing what we just did. Just plug in 1, and then 2, and then 3, and then 4 to find the specific term, right, for the sequence. Okay. All right, so let's take a look at the first really important formula that you need to understand how to work with. Okay. So this formula here is, first of all, for arithmetic sequences. Okay, so for arithmetic sequences, right? And it's called the general term formula for an arithmetic sequence, or sometimes they call it the nth term formula. Okay. Now, what do you use this formula for? Well, technically, you can use this formula to find anything in this equation, right, in this formula, right? So first of all, let's define a few things in this formula. U sub n is the term number, right? It's some specific term. Like if we want to find the 8th term, this would be u sub 8, okay? U sub 1 obviously is the first term, right? U sub 1, that's why there's a 1 there, it's the first term. N is the number of term, or the number of the term. For example, let's say I'm trying to find the 5th term, so that would be u sub 5. So n would be 5, okay? D, the common difference, right? We talked about that right now, the common difference. Okay. Now, so with this formula, right, or equation, sometimes they will ask you to find D. Sometimes they'll ask you to find N. Sometimes they'll ask you to find the first term. Sometimes they'll ask you to find a specific term, okay? So with this equation here, you have to be able to use it, right? Plug in whatever information they give you and solve for any part of this equation. So sometimes you have to find u sub 1. Sometimes you have to find n. Sometimes you have to find the letter d. Sometimes you have to find a specific term, okay? So when you're working with arithmetic sequences, you will be using this formula a lot, right? A lot of times you just plug in all the information that they give you into this formula, and then you'll solve for some unknown, okay? Let's take a look at the first example down here, right? So it says find the 125th term, right, of this sequence. Well, first of all, this sequence, we notice it has to be arithmetic, right? I know it's going to be arithmetic because if I do 8 minus 6, I get 2. If I take 10 minus 8, I get 2. If I take 12 minus 10, I get 2. I keep on getting the same value, so I know the common difference is 2. Okay, now this sequence goes on, all right, and then it keeps on going, all right, there's more numbers, and then we're trying to find the 125th term. So we're trying to find this, u sub 125, right? Like the next number here would be 14, right, and then 16, and we just keep on going. So this right here, 6 is the first term, this is the second term, the third, the fourth. We need to find the 125th term. Right, so it takes I mean, it's going to take a long time. We keep on adding 2. So that's what this formula here is for. If we want to find u sub 125, we can use this formula to find that answer. Okay, so if we're trying to find u sub 125, right, remember this represents the 125th term. Okay, now the formula says we take the first term. Do we know what the first term is? Yes, it's 6. We're going to add plus n minus 1. Remember, n is the term number, right? So this is the 125th term. So n is 125. Minus 1 times our common difference, we also know that. All right, the common difference is 2. Okay? So a lot of times, right, you just plug in the information that they give you into this formula, and you just solve for the unknown. Okay? So if we work this out right here, just use a calculator. So we've got 6 plus, and right here we're going to end up with 124 times 2, right? So 124 times 2 doesn't give you 248 plus 6, right? So our 125th term is going to be, all right, 254. Okay, so using this formula, you can find the 125th term very quickly, instead of keep on adding 2 a bunch of times until you find that 125th term. Okay. All right, let's take a look at another example that will involve, all right, the general term formula. So they want us to find the first term of an arithmetic sequence, and they're telling us the common difference is -5, and they're telling us the fifth term, right, a sub 5. Now remember I told you sometimes they're not always going to use the letter u, it could be different letters. A sub 5, so this means the fifth term, right? Fifth term is equal to 12, right? So we're going to plug everything into this formula. So a sub 5 is 12, so we know 12 is equal to, we don't know the first term, right? So u sub 1, or you use the letter a also too, it's really up to you. I'm used to using the letter u, right? Plus, now n, we know what n is. Remember, this is the fifth term, so this is n. n is equal to 5. So we have 5 minus 1, and we know the common difference is -5. So 5 minus 1 is 4. So if we multiply, we're going to end up with u sub 1, all right? And then multiply here, that'll give you -20, right? So minus 20 is equal to 12. Now we want to find u sub 1, we just add 20 to both sides. So u sub 1 is going to equal 32. Okay? So like I told you before, a lot of times you're going to use this equation a lot for arithmetic sequences, right? So whatever information they give you, right? Most of the time, you're going to plug it into this, right, formula, and you're going to solve for whatever they didn't give you, okay? All right, so let's take a look at this first example here, right? All right, so let's take a look at this first example here, right? So given this sequence, right, part A says, show that it is arithmetic, right? So how do we show that this sequence is arithmetic, right? So if we could show that there's a common difference, that will prove that it's arithmetic. So how do we find the common difference or try and show for it? We just subtract. 9 minus 2, what do we get? 7. 16 minus 9, what do we get? 7. 23 minus 16, what do we get? 7. So we notice we keep on getting the same answer. So this shows that this sequence is arithmetic, and we know that our common difference, right, is positive 7. Okay, so that's part A. Part B, it says write down the general term formula. Okay, so remember the general term formula. Remember the formula that we were working with, talking about earlier? U sub n is equal to the first term plus parentheses n minus 1 times d. So we're going to write the general term formula for this sequence right here. Okay, so u sub n is going to equal, now we know what the first term is, it's 2, right? So now we don't plug in, now we don't replace n with anything because it's just a general formula, right? It's not for a specific number. So we keep the n there. And we know the common difference d is 7, right? So if we distribute this, we're going to end up with 2, right? Plus, we're going to get 7n minus 7. So if we simplify this, we get u sub n is equal to 7n minus 5. So this would be considered the general term formula, okay? This formula, right, this general term formula represents how we can use this to find these numbers here, right? Like for example, if n is 3, if I plug 3 into here, 7 times 3 minus 5, right? So 21 minus 5, we get 16. So you notice right here, u sub 3 was 16. So the general term formula, I want you to understand what it represents, what it gives you. It's the formula, right, that will give you these numbers if you start plugging in values for n. Okay? So that's part B, the general term formula and how you find it. And then part C, right, find the 100th term of the sequence. Well, there's two ways to do this. Since we have the general term formula already, right here, 7n minus 5, well, if you want to find the 100th term, right, well, all you have to do is replace n with 100. So we would end up with 700 minus 5, so we'd end up with 695, right? That's our answer, okay? Now, let's say we didn't have this yet, and we needed to find, right, the 100th term, okay? So let's say we didn't have the general term formula yet, and we needed to find the 100th term. So another way to do this, right, if we didn't have the general term yet, so another way to do this is to use this formula here. So we're trying to find the 100th term, right? We know the first term of the sequence is 2, plus, now we're trying to find the 100th term, so n is 100, minus 1, and our common difference we know was 7, okay? So we're going to end up with 99 times 7, so 2 plus 99 times 7, that's going to give us 693. So we end up with 695 as our answer, right? So when you don't know the general term formula yet, this is how you would find a specific term, right, using this formula right here. Now, if you know the general term formula, remember we found the general term formula, 7n minus 5, then you can just plug whatever n is into here, and then it's a little bit less work, okay? All right, so let's take a look at some slightly harder problems. So example 2 here, right? So they tell us the fourth term, right, u sub 4, that means the fourth term of some sequence, right? We don't have the sequence. All they're telling us is the fourth term is 20. They're telling us the 13th term, right, is 65. And they want us to find the 23rd term. Okay, so when you're given this information here, so you have to remember the formula, right? So the nth term formula, like I told you, you use it a lot. So the nth term formula is equal to the first term plus n minus 1 times d, right? So we're going to plug what we know into this formula. Now, we know this is the fourth term, right? So that means that n is equal to 4, since this is the fourth term. So u sub 4, right? So we're going to have 20 is equal to the first term we don't know, so we're just going to keep it there, u sub 1. Plus, now n we do know. N is 4, right? So we have 4 minus 1. Now, do we know the common difference? We don't know that either, right? So we just plug in what we do know, though. So this simplifies to 20 is equal to u sub 1 plus 3d, okay? Now, over here, we have u sub 13, right? So u sub 13, I know n is going to be 13, is equal to 65, okay? So the 65 is this right here, right? U sub 13. So we're going to end up with 65 is equal to, now the first term I don't know, plus n is 13 minus 1 times d. Alright, so when you simplify this, you're going to end up with, right, 65 is equal to u sub 1 plus 12d. Alright, so what you're going to do now is you're going to take these two equations and you're going to set up a system. Alright, so I have this equation, I have the 65 is equal to u sub 1 plus 12d, right? So over here, now there's different ways to solve it from here. You could use substitution, you could use elimination, right? There's lots of different ways to solve this. I typically like to do elimination method, right? So what I'm going to do is, I notice the u sub 1s, I can get them to cancel if I can make one of them negative, okay? So that's exactly what I'm going to do. I'm going to make one of these negative. Alright, so I'm going to make one of these negative by multiplying by negative 1. So I multiply all this by negative 1, it's going to become negative 20, right, is equal to negative u to the first, or u sub 1, sorry, minus 3d, right? So if I multiply all of this by negative 1, this is what I'm going to get. So now, using elimination method, right, I notice the u sub 1s are going to cancel each other. So I'm going to end up with 9d is equal to, I add these, I'm going to end up with 45, right? So I divide by 9 on both sides. I've just figured out that the common difference d, right, is 5. Okay? So now that I know what d is, I can plug it in here to find the first term, right? So I know d here is 5, or I can plug it into this equation right here. Either one, it doesn't matter. So 65 is equal to u sub 1 plus 12 times 5. I know 12 times 5 is going to be 60. So if I minus 60 on both sides, u sub 1 is equal to 5 as well. Okay? Alright. So now that we know the first term, we know the common difference, we can find u sub 23. Okay? So I'm going to erase this real quick. So u sub 23, I'm trying to find the 23rd term. Now that I have everything I need, right, the first term I know is 5, plus n is 23. Now the common difference, d, remember that was also 5. So if I work all this out, I end up with 22 times 5, right? So we're going to get 5 plus, and 22 times 5, we're going to get a 110, I believe. So the 23rd term is going to be 115. Alright, so let's take a look at this example here. Okay, so we need to find the 52nd term of an arithmetic sequence, and we know the third term is 8, right? So that means that n is equal to 3 for this one. And over here, the 8th term, n is going to equal 8, is negative 17. So we use this information and we plug it into the nth term formula, or the general term formula, right? So right here, 8 is going to equal, the first term we don't know, we keep it there, plus, now n, we know n is 3 minus 1 times d. So this right here is going to simplify, and it's going to give us 8 is equal to the first term plus 2d. Over here for the 8th term, right, we know that negative 17 is going to equal the first term plus 8 minus 1 times d. So we're going to get negative 17 is equal to the first term plus 7d. And then we're going to set up a system again, right? So negative 17 is equal to u sub 1 plus 7d. And like we did with the last problem, I want to get the u sub 1s to eliminate, so I'm going to multiply one of these equations by negative 1. It doesn't really matter which one. Let's say I multiply this top one here, everything by negative 1. So I'm going to end up with negative 8, right, is equal to negative u sub 1 minus 2d. So when I add these two equations now, these eliminate, this and this will give me negative 25 when I add them. 7d and negative 2d is going to give me 5d. Alright, so d is going to turn out to be negative 5. Okay, now that I know what d is, I can plug it in here, or you can plug it in over here to solve what u sub 1 is, right? So I plug it in here, negative 17 is equal to u sub 1 plus 7 times negative 5. So that's going to give me u sub 1 is equal to, u sub 1 minus 35, because we get negative 35, is equal to negative 17. And then we add 35 on both sides, right? So u sub 1 is going to equal, that's going to give me positive 18. So now that we have the first term, we have the common difference, we can find the 52nd term. Okay, so that's what I'm going to do next. Let me erase this. So now that I have this information, I'm going to find the 52nd term. Right, so t sub 52 is equal to, the first term we know is 18, plus n, right, is going to be 52, because we're finding the 52nd term, minus 1 times d, our common difference, we know is negative 5. So if you work all this out, this is 18 plus, then we have 51 here, times negative 5. So 51 times negative 5, we get negative 255. Right, so our 52nd term, right, so negative 255, right, plus 18, that's going to give us negative 237. Okay. Alright, so this problem here, right, this is a slightly easier problem because you think about the information that they give us, right? We know the first term, so that helps, right? We know the first term, so that helps. We know the second term, and then we're trying to find the 50th term, right? Well, we could use, since we have consecutive terms, this is the first term of the sequence, this is the second term of the sequence, right? So we can just subtract them, right, to find the common difference. So if I do 8 minus negative 15, so the negative and negative become positive, so I know that that's going to give me 23. So I just figured out that my common difference is 23. Okay, so if I need to find the 50th term, I have the first term, which I know already is negative 15, plus n, which is going to be 50, minus 1, times d, which I just figured out was 23, right? So 49, so we end up with 49 times 23. We're going to end up with 1,127. All right, negative 15. So the 50th term is going to turn out to be 1,112. All right. So this problem was pretty easy because we had the first term already, and the next term they gave us, right, was the second term. So it was easy to find what D was. Okay, so some problems will be kind of easy, some are a little bit more challenging. It just depends on the information that they give you. All right. All right, so let's take a look at this problem here. So they gave us the 42nd term is 242. They give us the common difference, and we need to find the first term and then the general formula. Okay, so once again, like I told you, we're going to be using this equation a lot, right? The general term formula. So we know the 42nd term is 242. The first term, sorry, this should be the first term right here. The first term, right, we don't know, we're trying to find that. Plus n, which we know is 42 minus 1 times d, and they give us d is 6. Right, so this is going to be 41 here times 6. So we do 41 times 6, and it'll be 246. So 242 is equal to u sub 1 plus 246. So if we minus 246 on both sides, u sub 1 is going to equal, right, we're getting negative 4. So we just found the first term. Okay, so we just found the first term. Now we need to find the general formula. Alright, so the general formula, we just use this. Right, to find, anytime you're finding the general formula, you just use this. This is the general formula. We just need to plug in the first term and the d. Okay, so to find the general formula term, alright, the general term formula, right, we're going to plug in the first term, which we just found, and then the common difference d. So u sub n, right, is equal to the first term, negative 4, plus, which is going to keep the n there, minus 1, and d is 6. So if you distribute the 6, we're going to end up with u sub n is equal to negative 4 plus 6n minus 6. So the general term formula for this information would be 6n minus 10. Okay? So first of all, you use this formula, right, for a finite, right? So the sequence, the arithmetic sequence must end, right? It must have a last number, okay? For a finite arithmetic sequence, okay? Now, if an arithmetic sequence is infinite, it's impossible to find the sum, okay? So we'll talk more about that later, but just keep that in mind. If an arithmetic sequence is infinite, it's impossible to find the sum, okay? All right, so let's take a look at this formula here. So S sub n, this means that we're just trying to find the sum of some amount of terms, right? Of some number of terms. Like if they tell you find the sum of the first 80 numbers, n would be 80, right? It's S sub 80. Now, the important thing about this formula that you need to understand is you need to know the first term, and u sub n here is the last term. Is the last term of the sequence. Okay. Right. So, and obviously n is the number of terms, right? But anytime you're trying to find the sum of a finite arithmetic sequence, you need to know the first term, the last term, and n. Those are 3 things you need to know to find the sum, right, of an arithmetic sequence. Okay. So let's take a look at an example. It says find the sum of the first 150 terms of this sequence, right? So here's the first term, right? Here's the second term, the third term. We need to find the sum of the first 150 terms, okay? So the sum formula, right, we just talked about this, is n divided by 2 times the first term plus the last term, right? Now we know the first term right here. So we know the first term. We know n is going to be 150 because we're finding the sum of the first 150 terms, right? So n is going to be 150. What we don't know is we don't know the last term, right? So we need to find, right, u sub 150. Now the last term is going to be the 150th term, okay? Because we're finding the sum of the first 150 numbers, okay? So we need to find this right here. So to find this right here, we're going to use the general term formula. So remember the general term formula, we have the first term plus n minus 1, right? So 150 minus 1, so we get 149 times d. Well, let's find d because we have all these numbers here. We can find d. If I do 16 minus 5, I get 11. If I do 27, right, minus 16, I get 11. So I know the common difference is going to be 11. Okay, so with this information, right, I can find the 150th term. So I have 149 times 11 plus 5. So the 150th term is 1,644. So the 150th term is 1,644. So now that I know this, right, and I know the first term, I can plug everything into this formula to find the sum of the first 150 numbers. So the sum of the first 150 numbers is equal to 150 divided by 2 times the first term, which is 5, plus the last term, the 150th term, 1,644. And then you just work all this out. So this is going to be 75 times 1,649. So let's just throw that in the calculator. 75 times 1,649. So we're going to end up with the sum of the first 150 terms is 1, 2, 3, 6, 7, 5. 123,675. Okay? Let's take a look at this example here. Now, we're finding the sum, right, of this sequence here. So you notice we have the first term here, right? We have the first term here. We actually have the last term also, right? We have the last term also. The problem here is we don't know what n is, right? All we know is this is the first term. There's some numbers, right? There's some more numbers that are going to be in between. And then this is the last term. So we don't know what n is. So we have to find out what n is, okay? So what we're going to do is I'm going to use this last term to help me find n, right? So we're going to use the general term formula, right? So 141 is going to equal, right? So you remember the general term formula, right? U sub n is equal to the first term plus n minus 1 times d. Now we don't know what, actually we'll find out what d is in a moment. We don't know it right now, but we could find out what d is. Now the first term we know is -6 plus n is what we're going to find, right? Because that's what we don't know. And the common difference d, we're going to use these numbers to find out what d is. So 1 minus -6, I'm going to end up with negative is positive. I'm going to end up with 7. 8 minus 1, I end up with 7. So I notice I get the same value. I know d is going to equal 7. So d is 7. So if I distribute this in, I get 141 is equal to -6 plus 7n minus 7, right? So 7n minus 13 is equal to 141. So I just solve for n, right? So 7n is going to equal, I add 13 on both sides, so that's going to give me 154. Divide by 7, right? So 154 divided by 7, I end up with 22. So what that tells me is this sequence has 22 terms, right? And the last term, the 22nd term, is the 141. So if I want to find the sum of the 22 terms, so S sub 22, right? The sum of the 22 terms is going to equal 22 times, 22 divided by 2, right? I'm just using the sum formula. The first term is -6 plus the last term, which is 141. So I throw all this in the calculator. This is 11. This is going to give me 135. So 11 times 135, I get 1485. So the sum of the first 22 terms, right, of the 22 terms is 1,485. Okay.